In this video, we are going to talk about complex numbers. And under complex numbers, we are going to talk about addition of complex numbers, subtraction of complex numbers, division of complex numbers, and multiplication of complex numbers. I will urge that you watch this video to the end in order to understand the concept behind all these principles. So to begin with this video, I'll urge that if you are new to this channel, you would subscribe and also put us on post notification in order to get more content from us. Let's move on. Suppose we have a complex number a plus bi. The real part is a and the imaginary part is b. So let's move on to solve a question. So for example, if you are asked to add two complex numbers, for example, given that k is a complex number and is equal to 2 plus 3i, and p is a complex number given by 6 plus 4i, then k plus p will be equal to 2 plus 3i plus 6 plus 4i. Now, if you are adding complex numbers, you are supposed to add the real part to real part and imaginary part to imaginary part. And so you cannot add these two to an imaginary part like 4i. You are supposed to add these two to a real part like 6. And so for this question, we will add 2 to 6 and 3 to 4. So we are going to get 8 plus 7i. Also, when we are to subtract complex numbers, for example, when we are given that find k minus p, then we write it as 2 plus 3i minus open bracket 6 plus 4i, because you are supposed to make sure that the subtraction sign affects both the real part of p and the imaginary part of p. So we are going to get 2 plus 3i minus 6 minus 4i. Then we get the final answer to be negative 4 minus I. Also, when we are asked to multiply two complex numbers, for example, in this case, k times p, we should note this principle behind complex numbers. When we know that I is equal to root of negative 1, and so I squared will be equal to negative 1, because when you square a square root sign, for example this, when you square root of a, you are going to get a to the power half. Let's say you square this, you're going to get a to the power half times 2, right? Then this 2 will cancel this 2, leaving a to be equal to just a. So I squared will be equal to negative 1. And so let's come back to the multiplication of these two complex numbers. So we know that k is equal to 2 plus 3i and p is equal to 6 plus 4i. So this follows the normal algebraic multiplication, but we should take note that I times I squared will be equal to -1, because most of the time students make this mistake and it affects the whole calculation. And so for this, we are going to multiply 2 by the 6 and 2 by the -4, and also 3i by 6, then 3i by 4i. So we are going to get 2 times 6 plus 2 times 4i. Then we also get 3i times 6 plus 3i times 4i. So for here, we are going to get 12 plus, now this one will multiply just the 4, and so you are going to get 8, then you add your i, right, plus, same thing applies to this, 3 times 6, which is 18i, plus, now for this, you are going to multiply 3 by 4 and I by I. So we get 12 multiplied by I squared. But we already know that I squared is equal to -1. So therefore, we get 12 plus 8i plus 18i minus 12, because the negative one here will replace this I squared, and we get 12 times -1, which is equal to -12. So since we have 12 minus 12, we get 0 for that part, then we get 26i to be our final answer for the multiplication of the complex number k and the complex number p. Now, say we are asked to find the division of complex numbers. We have something called conjugation of complex numbers. So if we have a plus bi and we are asked to find the conjugate of this complex number, the sign is going to change. So the sign that is for the b, the imaginary part, is the one that is going to change. And so if we have 3 plus 2i and we are asked to find the conjugate, we are going to get 3 minus 2i. If we have minus 3 minus 2i and we are asked to find the conjugate, you are going to get minus 3 plus 2i. The sign of the real part is not going to change. It is just the sign that is attached to the imaginary part that is going to change for conjugation. So if you are asked to find p divided by k, now from the question we know that p is equal to 6 plus 4i and k is equal to 2 plus 3i. So if you are asked to find p divided by k, you have to multiply this term by the division of the conjugate of the denominator. So we are supposed to find, we have to multiply this whole term by a ratio of the conjugate of the denominator, and so we are going to get this term multiplied by 2 minus 3i divided by 2 minus 3i. So for the denominator aspect, normally we can use the shortcut of difference of 2 squared for the denominator part, because we know that this is a plus and this is a minus, and so we are going to get difference of 2 squared, and so we take one term, this term, we square it for the denominator, minus we take the other real term, then we square that one to 3i squared. Then for the numerator, we do a multiplication of complex numbers, as in like the one we did for the first part. And so for the numerator, we are going to get 6 times 2, which is 12, minus 6, plus 6 times minus 3i, which will give you a minus, and so we are going to get minus 18i. Then we do same for 4i, so 4i times 2, which is 8i. Then plus 4i minus 3i. Then we get, for that we are going to get negative 12i squared. Now, as we said previously that I squared is equal to negative 1. Please try not to forget this. I squared is equal to negative 1. And so the numerator aspect will be, the numerator aspect is going to be 12 minus 18i plus 8i plus 12, right? Because the I squared is going to be negative 1, and so negative 12 times negative 1 will give you 12. Then we are going to get divided by 4 squared minus 3 squared, which is 9, multiplied by I squared, which is negative 1, right? So we are going to get this place to be negative 9. Then we get our final answer to be 24 minus 10i divided by 4 plus 9, which is 13. Then we get this to be our final answer. Thank you for watching this video to the end. Do well to like, comment and subscribe to the channel. This is Okonkwo Academy. Share this video to your friends who have problems in complex numbers. Thank you for watching.